Good morning, fifth grade online learners. Welcome to January 14th, 2021. It is a Thursday in science class with me, Mr. Monzo. Me, not you, Reese, me. Okay, so we're going to do a brief review because we have a quiz tomorrow. Today we have a journal entry. By the end of today, you have 3 journal entries that should be done. These will go on the next 9 weeks report card because we won't have a chance to record the grades until tomorrow, and the 9 weeks ends today. So, anyway, we are learning about change in motion. We've been learning about that all week, and I thought I would see if people would know the answers to these questions. We have Mr. Giovanni's class in here. So, how can an object's speed or direction be changed? Does anybody know? Nobody knows how an object's speed or direction can be changed. What can we do to that object? Freddie? Okay, add motion, and more specifically, we can say we can add a force. And by adding the force, you're doing a motion to add the force. So Freddie, you are correct. How can an object's speed or direction be changed? A force can be applied. Number 2, what is the difference between velocity and acceleration? Give an example of each. Does anybody know the difference between velocity and acceleration? It's a little bit tricky question, guys, because we've been studying this all week, and the best thing I would do for that is I would look at my study guide, which I printed out, and it is on Google Classroom. Who can read the definition of velocity for me? Brooke.
A measure of both an object's direction and speed.
Okay. A measure of both an object's direction and speed. That is velocity. Acceleration. Brooke, would you read the definition for acceleration?
A change in an object's velocity.
Okay, a change in the object's velocity. So velocity is a measure of both an object's speed and direction, and acceleration is a change in the object's velocity. So often with a car, we say, step on the accelerator, give it some gas, and that way we're making the car go faster, okay? We're making it go faster, and you may have the option of changing the direction of the car also while you're increasing the speed. Number 3, what are 3 ways an object may accelerate? Anybody have any ideas? All right. Oh, do you know, Ava? Oh, good. Awesome job, Ava Cohan. An object may speed up, it may slow down, and one other way is it might change directions. Okay? So those are the 3 ways it may accelerate. Speed up, slow down, or change direction. Number 4, explain why the shoulder strap of a car seatbelt is important. Okay, guys, back in the olden days, with the older cars, in the really olden days, they didn't even have seatbelts. It was an option. Imagine how scary that would be. And I'm talking about not that long ago, like 1960s. That sounds long for you guys, but it's not that long for me. Addison.
And weren't there a lot of car crashes?
Yes, car crashes. So we added seatbelts to go around your lap. And then in the 70s or 80s, we added a shoulder strap. Can anyone tell me why that's so important? Brooke.
Because if you go to a car crash, you'll just pull back so you don't go forward and you don't hit your head.
Okay, good. The lap belt's going to keep you in your seat, but the shoulder strap's going to keep your whole upper body from going forward. Freddie, what were you going to say?
If you crash, you won't slip out. It's not hard enough.
If you crash, you what?
If you crash and it's not hard enough, you fly out.
You might go out of the vehicle. Without a seatbelt, there's a very good chance you would end up outside of the vehicle. And your chances of survival are a lot better if you stay in the vehicle. If you're flying out of it, you don't know what you're going to hit into. So seatbelt, lap belt keeps you in your seat. Shoulder belt keeps your upper body intact, like from moving forward. And some race car drivers even have a seatbelt on their helmet. It's called a HANDS device. And so if they hit something really hard, they have a seatbelt here, and they have something that holds their head from going like this. Because they could hit something at a lot faster speed, and they could get hurt or killed. So the more seatbelts you have, the better. And to think there was a day when we didn't even have seatbelts is crazy. Reese.
I saw this true story. It was because this girl was going to a show and she just got her driver's license, and her GPS was like going off or whatever, and she tried fixing it, and she just tried getting in the map, and then she hit a pothole and she didn't have her seatbelt on, and she flew out of the window.
It happens, guys, and it used to happen more frequently. That when people got into car wrecks, if there wasn't a seatbelt, you do end up outside. You could end up outside the vehicle. So, we've come a long way in, 60 years since the 1960s, when you could order a car without seatbelts, and there was no law about seatbelts. Now, if you're not wearing one and you get pulled over, they can actually give you a fine for pulling you over, and a fine for not wearing your seatbelt. So all this deals with safety and everything we're learning about, acceleration, velocity. Here's one more question. The brakes on a bicycle slow it down due to the force of what? How do the brakes on a bicycle slow you down? What's one of our vocabulary words that would describe what's happening? Addison.
The wheels stop.
Okay, but think of a vocabulary word from your study guide. What does it cause? Ava Cohan? Very good job, Ava Cohan. Friction. Friction is applied from the brakes to the rim, and that slows you down. And same thing with cars, guys. Their brakes aren't as visible because they're covered by the wheel. As opposed to a bicycle, you can see them, but cars slow down the same way. You have a brake pad, it squeezes against the rotor, it causes friction, you slow down. Inertia, that's a word we don't use very often. The idea of inertia is an object will remain at rest or in motion until a force is enacted upon it. Sir Isaac Newton came up with that law. It's the first law, Newton's first law. Something's rolling, it's going to keep rolling until something slows it down. If something's sitting still, it's going to stay still until something moves it. Motion is a change in an object's position. Velocity is a measure of both an object's direction and speed. Force is a push or a pull that acts on an object. Friction is a force that resists motion of one surface across another surface. Acceleration is a change in an object's velocity, speeding up. Gravity, something that causes objects with mass to be attracted or pulled toward another. So we have gravity on Earth, and we're always getting pulled towards the center of the Earth. We never get there, but it keeps us on the ground. Speed, a measure of distance that an object has in a given amount of time. And Newton, the force required to accelerate a mass of 1 kilogram at 1 mile per second, or 1 meter per second. That, unfortunately, is on the quiz, guys, but I tried to make the answer pretty obvious. So know that last vocabulary word, but know that I tried to make the multiple choice real obvious. Like, only one word can possibly fit in there. The other words are just, they don't make sense in the sentence. Key concepts. Air resistance is friction that slows an object traveling through air. An object will accelerate or change its motion only when an unbalanced force acts on it. Acceleration can either be a change in direction or a change in speed, or both. A ball traveling through the air is in motion. Velocity can include a change in direction of a runner. Force is needed to stop an object in motion. Division is needed to calculate average speed. A force is needed to move an object or it will remain at rest. So those are ideas. I can guarantee you that the vocabulary words are definitely on the quiz. And then there's maybe 1 or 2 key concepts that are on the quiz. See if there's anything else I want to say. Quiz is tomorrow. Please study the study guide because there's 9 vocabulary words. That's a lot to remember. Does anybody have any questions? Okay, I did tell the class here that for enrichment, if you're done with all your work, if you go on Google, the main page, go to MOSA Mac enrichment. I added some chapters to that, and this is all if you need more to do in science. You're sitting at home or sitting in class and you're like, I just want to explore these concepts further. There are 3 chapters to each lesson. This is not required, it's just optional, but it's a pretty good program. Videos, all kind of different activities. I think there's even some experiments you can do at home. Let me check the time, and we are doing well. And do your journal entry for today based on the website, 3 for this week, and do your quiz, and we'll do a brief review tomorrow. Bye-bye, online learners. I waited till it went to 11 minutes. I had to wait 10 seconds. Nobody will ever notice. What's that?
You should get a TikTok account.
You think? What if I do Corvette?
How does he know that?
Only because Juju did it. Juju Smith-Schuster.
Do you have TikTok? Mr. Monzo, do you have TikTok?
Do I have TikTok? No.
Why not? You'd be famous.